main example 7 main for I is equal to n, for I is equal to n, I greater than or equal to 1, right? I greater than or equal to 1. Next, let me write now. I is equal to I minus n by 2. X is equal to y plus z. For I is equal to n, otherwise let me write here. I is equal to 1, I less than or equal to n, I is equal to I plus n by 4. X is equal to y plus z. I is equal to 1, I less than or, I greater than or equal to 1, I is equal to I minus n by 2. I is equal to 1, I less than or equal to n, I is equal to I plus n by 4. Can you try once? What is the answer of this? Let's see how many people will do. If you start from big number, subtract. If you start from small number, right? If you start from small number, add. Start from big number, then you have to subtract. Start from small number, then you have to add. Already, suppose assume that already starting with big number, you cannot add because is already big. Right? If you start from small number, you have to add because is already small. You have to add. Let's see how many people will give answer for this. First of all, two statements are there. First of all, there are two statements. First statement, second statement. First statement is how many times check. Second statement is how many times verify. First statement is how many times. Second statement is how many times. Please verify yourself. Please verify yourself. Sunny, please verify. First statement is how many times. Second statement is how many times. Please verify. Yeah, try anyone. Can anyone give answer? What is the answer of this? Now I want to explain everyone. It's very simple. So please don't do every time blindly. Please don't do every time blindly. Yeah. Please don't do every time blindly. My sincere request is please don't do every time blindly. That is the reason I given this problem. Let me check once. Let me check. Let us assume that n value 20. Assume if n value 20, first to 20 greater than or equal to 1, condition true. Next time 20 minus n value 20. So 20 minus 20 by 2, 10 subtracted. So it became remaining is 10 only. Right? Next round 10 is greater than or equal to 1, condition true. Condition true. Right? So first to 20 greater than or equal to 1, condition true. Right? Next one, second time I value is 20 minus 10, 10. Now I value became 10, 10 greater than or equal to 1. That is also condition true. Right? Next time, right? Now I value becomes 10, 10 minus, right? So 10. Remember, I is updating, n is not updating. I is updating, n is not updating. So I read n value is still 20, 20 by 2 is 10. 10 minus 10 is 0. So 0 greater than or equal to 1, condition is failed. So remember everyone. So right, first to 20 it will work out. Next to 10 it will work out. Right? Next to 20 it will first to 20 worked out, 10 worked out, 0 it don't work out. So first loop is 2 times. First loop is 2 times. Now can you see this one? Let us assume that in the right. Let us assume n value is. Let us assume that n value 20. Now see the answer. N value 20. First one. I value 20. Sorry, I value 1. Assume that n value 20. So I value initially 1. 1 is less than or equal to 20. Condition true. Then what he is doing is I is equal to 1 plus 20 by 4. 20 by 4. I think 5. So it will become 6. Next round 6 less than or equal to 20, condition true. Next one 6 plus 5, which is going to be 11. That is also true. 11 less than or equal to 20, condition true. Next 11 plus 20 by 4 means 5, which is going to be 16. That is also true. 16 less than or equal to 20, that is also true. Next one 16 plus 5, 21. 21 less than or equal to 20, condition failed. So if you observe clearly, only 4 times going on. So second loop is only 4 times. Second loop is only 4 times. First loop is only 2 times. So order of magnitude of every statement you done. So if you see the order of magnitude of total program, it became 6. It will become big O of 1. Time complexity of this program, big O of 1. Time complexity of this program, big O of 1. So please use common sense. Don't do blindly. Please use common sense. Don't do blindly. Array, see this one. Always you are subtracting n by 2 here. If you write n contain 2 n by 2s. N contain 2 n by 2s. From the n, always if you subtract n by 2, only 2 times you can subtract. Next one, n contain 4 n by 4s. Always if you keep on adding n by 4, n by 4, n by 4, after 4 times it became n. Afterwards it will fail only. So what I mean to say is please check properly. Please check properly. See, n contain 4 n by 4s. It will execute only 4 times. Right? Next one. N contain 2 n by 2s. It will go only 2 times. Don't go blindly. Don't go blindly like this one. See this one. Here there is some logic. Always by 2. Always by 2. Remember. Always by 2. Right? Log n base 2. Always into 2. Log n base 2. Always minus 2 n by 2. Always plus 2 n by 2. Right? Remember, they are the standard things. If you want, you can try proof also. If you try this one, you will get the proof also. See this one. One geometric, right? See this one. 1, 2, 4, 8. I think one GP series going on. You solve it, you will get the same answer log n. Here also one GP series going on. You solve this, you will get the log n. Here also you will get the one AP series. Right? Here always subtract, always adding to. One AP series will come. So I think first one 1, next one 3, next one 5, next one 7, next one 9. One AP series going on. You solve it, you will get the same answer n by 2. Here also one AP series n. Next one is 2 to subtract n minus 2, n minus 4, and so on. Lastly, one. Here also one AP series. You solve this AP series, sum of all the terms in the AP series you find out, you will get n by 2. It is also n by 2. Now, this GP series you solve, you will get log n. This GP series also you solve, it will also become log n. Do these proofs also possible. If you want, you can verify. Right? But here, it is a common sense. It is a common sense. One n contain 2n by 2s. If you subtract always n by 2, 2 times only you can subtract. One n contain 4n by 4s. If you subtract, right, if you add always n by 4, n by 4, n by 4, after doing 4 times, it became n. Further, it will fail anyhow. So, time complexity of this program is constant. Every constant can be written as big O of 1. Remember, every constant can be written as big O of 1. This is the way of writing constant. In algorithm terminology, writing constant is like this, big O of 1. In algorithm terminology, writing constant, any constant you can write. Suppose 100 is a constant, you can write like this, big O of 1. Suppose 5 is a constant, you can write like this one, big O of 1. Suppose 20,000 is a constant. Every constant can be written as big O of 1. Every constant can be written as big O of 1. In algorithm terminology, every constant is same. In algorithm terminology, every constant is same. If you think this program time complexity constant, simply write big O of 1. Simply write big O of 1. I hope everyone is comfortable. Let's move to one more problem. Example, I think 7 over, I think 8. Example 8. Example 8. Example 8. Main for I is equal to, main for I is equal to 1. I less than or equal to n. I into is equal to 7. Always multiplying by 7. Always multiplying by 7. Next one, for I is equal to 1. I less than or equal to n square. I into 7. X is equal to y plus z. For I is equal to n square. I greater than or equal to 1. I divide is equal to 7. X is equal to y plus z. Next one, for I is equal to, for I is equal to 1. I less than or equal to n square. Let me write one small line. For I is equal to n power 7. I greater than or equal to 1. I divide is equal to 9. X is equal to y plus z. End of the program. Can you try this? What is the answer of this? What is the time complexity of this program? It is the example number 8. It is the example number 8. Can you check this? First of all, identify how many statements. Please go to every statement. Please verify how many times that loop is going on. Go to every statement. Please verify how many times that statement is executing. Right? Let's see how many people will give answer. What is the time complexity of this program? Every statement order of magnitude find out. Every statement order of magnitude find out. Yeah. Can I give answer? Yeah. Let me try answer. Let me try. Most probably your answer is right. Let me give answer. See, first statement order of magnitude. Try properly. Always multiplying by 7. Log n base 7. Check properly. Always multiplying by 7. Log n base 7. Now listen. Now listen this one. This also always multiplying by 7. Listen. This also always multiplying by 7. It is also log n base 7. Remember, n there log n base 7, n square there log n square base 7, whatever there, that one. If n is there log n base 7, n square there log n square base 7. Now what about this one? What about this one? What about this one? Let me check. Log n square base 7. What about this one? Same thing. Always divide by 7. If at all always divide by 7, log n base 7. If at all n there, but n place n square there, log n square base 7. It is also same, always by 9. This is also log n base 9. If n is there, n place n power 7 there, n power 7. Always divide by 9, right? Log n base 9 if n there. If n power 7 there, log n power 7 base 9. Always divide by 7. Log n base 7 if n there, but n place n square there. Keep n square. So careful everyone. Now some people are asking, sir, this can be written as this one. This can be written as log n base 7. This can be written as 2 log n base 7. This can be written as same 2 log n base 7. This can be written as 7 log n base 9. Add all of them. Add all of them. First one is log n base 7. Second one is 2. Let me write now. Log n base 7 plus 2 log n base 7 plus 2 log n base 7 plus 7 log n base 9. So forget about all the constants and all. Constant cannot affect anything. Answer is big O of log n. Forget about base, whatever it may be the base. Right? All bases are differ by constant. All bases are differ by constant. So the answer of this one, log n, that's it. The answer of this one, log n. The answer of this one is big O of log n. Don't worry about the base. Don't worry about the base. right? Don't worry about the base. Answer is big O of log n. Answer is big O of log n. Anyone having small doubt also? Some small twist I kept in this problem. In this problem, I kept a small twist. In this problem, I kept a small twist. In this problem, I kept a small twist. N place, I kept n square. N place, I kept n square. Log n square base 7, which is going to be 2 log n. Log n square base 7, which is going to be 2 log n. Log n power 7 base 9. 7 will come left hand side. 7 log n base 9. So this is the final answer. Let me know if anyone having any doubt. So Sunny, are you okay? Sunny, do you have any doubt? Sunny, do you have any doubt? Yeah, let's move to one more problem. Example number 8 over example number 9 you see. Example number 9. Main. Example number 9, main. For I is equal to 2, I less than or equal to, I is equal to 2, I less than or equal to n, I into is equal to 2, x is equal to y plus z. For I is equal to 70, I less than or equal to n, I into, right, I into is equal to 4, x is equal to y plus z. For I is equal to, for I is equal to 89, I less than or equal to n power 20, I star is equal to, I star is equal to 13, x is equal to y plus z. Yeah, can anyone help me? What will be the answer of this? It's a very interesting problem. Let's check. It's a very interesting problem. Let's see how many people will give answer. It's a very tricky. It's a very tricky problem. It's a very tricky. Let's see how many people will be. Yeah, let's see the story. Let's see the story once. Let's see the story once. This is going, I think, always, right, by 2, always into 2, always into 2. See this one, always into 2. It is going to be log n base 2. Listen, log n base 2. You may say that, sir, this is going to be log n base 2 if you start from 1. If you start from 1, then log n base 2. Sir, you started from 2. I think a few terms are missing. Actually, you have to start from 1. Because of I started from 2, few terms are missing, no problem at all. If you want, you can subtract -2, no problem. If you start from 1, then log n base 2. Because of you started from 2, few terms are missing. So missing terms, if you want, you can subtract. Right? So I think some people are asking, missing terms are from where to where I missed out. So 1 to 2 I missed out. If you start from 1 to 2 you missed out. I think 1 to 2, how many times? Because of always multiplying by 2, log 2 base 2. Nothing there. If anyone is not getting, you may get more clarity here. Can you see this one? If you always multiply by 4, everyone listen. If you always multiply by 4, log n base 4, that is okay. But remember, if you start from 1, log n base 4, because of you started from 70, so what is the meaning? 1 to 70 you missed out. Right? Larger number is what? 70. If you want, you can do log 70 base 4. Because some terms are you missed out. If you start from 1, log n base 4, because of you started from 70, 1 to 70 you missed out. 1 to 70 how many times? That is also log only, but log 70 base 4. So if you, because of anyhow log 70 base 4 constant, you can neglect. Anyhow log 2 base 2 is a constant, log 2 base 2 is one constant, you can neglect, no problem. Next one, can you come here? Can you come here? Always multiplying by 13, log n base 13. Listen, log n base 13, if n is there, but n power 20 there, n power 20. Log n base 13, if n is there, n power 20 there, keep n power 20. But remember, if you start from 1, that is the story. But you started from 89. What does it mean? 1 to 89, you missed out. 1 to 89, what is the answer? Because of always multiplying by 13, same effect. Log 89 base 13. But anyhow, log 89 base 13 is a constant. You can neglect. So finally, if you see the total story, right? So order of magnitude of total program, log n base 2 plus log n base 4 plus 20 log n base 13. Forget about constants. If you see bigger term, log n. Answer is big O of log n. Answer is big O of log n. You no need to bother. You no need to bother. What is the base? You no need to bother what is the base. It is the 9th problem. It is the 9th problem. Answer is log n. So today, excellent class happened.